And oh, sorry. Okay, let me mute this. Okay. So I think this pattern is really important because LMs lack specialized expertise, and typically, if you want to shape a certain type of behavior, you would improve the LLM by fine-tuning the large language model on some training data. On the other hand, if LM has no access to like specific information or like a knowledge base of sorts, you typically want to use RAG to overcome this issue. And so what vector database does is that it helps you to do this portion. So it's super simple. You have a query, you retrieve relevant chunks of data from the database, and you feed it to a large language model context with the query. And now the LM has access to all the information in that database. So again, just for reference, a user gives a question to chat UI, you do the similarity search, and then you just push it back to the large language model. And this is going to be your retrieval augmented generation pattern that honestly most companies or products are using today. So what we have provided for you guys for this hackathon is 3 simple ways to use Iris vector search. You can use it natively in SQL. This is, I think, the most preferred way. It is the most native way to how we do it, and it's also super flexible because vectors are simply like another column. So you can search other columns really simply as well. We also have LangChain and Llama index integrations that under the hood just run SQL. So frankly speaking, I think the first way is the most flexible way, but these frameworks are also really useful if you just want something quick and dirty. So, sorry about that. That's the old link. But I think if you go to the booth, we have a QR code to the GitHub, and I can just show it right here real quick. So it's just HackMIT. So this, you can try and look it up online, InterSystems community HackMIT. And what this has is a couple of demos to get you started really quickly. So there are 2 main ways to approach this. You can use a container, where the Iris database is in a container, and the demo, the Jupyter notebook, is also in a container. And you just Docker goes up, you can follow the instructions, and you can get it set up. Or you can use your local Python environment. I think this is better. So Iris will live in a container as a database. Then your dev is just Python on your own computer. And then you'll connect to the database and just run commands on it. So if it sounds complicated, it's really not, because we have all these really simple instructions, and we have all these demos over here that you can take a look. So these demos are all in here, like in the demo, you have the SQL demo. So for example, over here is all you're doing, it's all the connection part. And after that, you can make SQL queries just like this. So all these notebooks are examples that you can get started with, and I highly recommend checking them out if you need any sort of semantic search, any sort of database for today. Go have a look. So over here we have a really simple example of having a data set of whiskey reviews, and what we're doing is putting them through an embedding model to create vectors, and storing these vectors in Iris. So what you see here is all these columns like name, category, price, currency, and all that. And what's really great is that you're able to search. Let me just scroll down to it. So if you look at the query over here, you're able to search your database for a semantic search of something similar to what you searched. Over here, I searched like earthy and creamy taste. And I could also search based on the price column, where price is less than $100. So this is really powerful if you have any additional metadata that you want to add to your data. So you can search based on the unstructured data and also the structured data, which is all your numbers and any exact matches if you want. So that was a really, really brief demo of what we have. So our challenge is simply, best use of Iris. Iris is the name of our data platform, vector search for any GenAI application. And we have really good prizes there. Honestly, not the most difficult to win. The first prize, $2,000. Second prize, $1,500. Third prize, $1,000. Cold hard cash. So I highly recommend if you need any sort of like RAG in your GenAI application, just get started with our repos and let us know if you have any issues. And this should be able to get you pretty far and qualify you for our challenge. And so feel free to come by our booth. We are also actively recruiting. So summer internships for 2025 or new grads 2025. We are actively recruiting right now, so come by our booth. We have this iPad or like these links where you can put in your resume and stuff, and this will get in your process. So I think that's all I have. Do we have any questions?
So I remember you mentioned that you brought a lot of health data. So like this is what I'm guessing, but is this vector search in future going to integrate with protein embeddings as well, like with AlphaFold?
So the best part about just doing vector search is that I'm only dealing with vectors. I don't care what embedding model you use. So if you already have a protein embedding model, you can already use this for vector search. I think a really fun and interesting domain is multimodal embeddings, where people are mapping both images and text into the same vector space. And what it means is that you can do image-to-image search, you can do text-to-text search, you can do image-to-text search, and text-to-image search. Because they're all in the same vector space, and we're all just doing vector search by comparing the distances. So that results in a lot of fun applications that you can build. That's an example. A more niche example is what you said. Some people use domain-specific embeddings, like for finance, for example. There are also finance. There's a lot of finance jargon that maybe standard embedding models are not as good at. So if you could experiment with all of them, as long as you're a vector, you can use them in our database. So yeah, we are also very happy to take questions, or if you just want to brainstorm or like get feedback on your ideas, come by and chat with us. Even if it's honestly like, even if you guys aren't using our stuff, like we're just happy to talk anyway. So yeah, any other questions?
Wait, so do you guys use cosine similarity or?
Yeah, so we have dot product and cosine similarity. Yeah, you can choose. So it's inserting your vector dot product. But so cosine similarity is just vector dot product for that's normalized. So if you already have normalized data, just use dot product, it's faster. But it's a small thing. Any other questions? If not, awesome. Happy hacking, and I'll stay here for 5 minutes for any questions if you guys want to talk. And all the best. Thank you.
What are you using exactly?
Yeah. Okay.
I wanted to ask.
What? Yeah.
Yeah.
Thank you.